Hello guys, welcome back to the channel Engineer Study. In previous video, we start instruction set in 8051 microcontroller with introduction. Now, in this video, we will see data transfer instruction set in detail. As per name, this instruction set are used to transfer the data from one location to another location, but without changing the binary information contents. Means data transfer but contents of data is as it is. No flags are affected by using this instruction set cause data is transferred as it is, so there is not any changes like overflow, parity, carry. Means not any flags are affected by using these instructions as per PSW. There are three types of instructions in this instruction set. First is move, second is push and pop, and third is exchange. By using these three types of instruction, data can be transferred. First is move instruction. Its syntax is opcode destination comma source. Here opcode is always MOV move and the data is transferred from source to destination in this way. Here data is copied from source to destination. After transferring the data, the same data is available in the source also. That's why it's called copy instructions. The move instructions are move a comma hash data means immediate data. Move a comma rn, here rn is r0 to r7 registers. Move a comma address. Move a comma @ri, here ri is r0 and r1 registers. Move x a comma @dptr. This instruction is used to transfer the external data. Move c a comma @a plus dptr. This instruction is used to transfer the data on coded address. Now see first instruction. Move a comma hash data with example. Move a comma hash 25h. Now see how can explain the instruction with step by step. Here 2 bytes are used to store these instructions. How? One for opcode, cause opcode is always 8-bit long, and in operand 8-bit data is present, that's mean 1 byte. So total 2 bytes are used for these instructions. Next is addressing mode. Here immediate data is present, that's why this is immediate addressing mode. To understand instruction set, you should be aware of addressing mode. Please go through that video. Link is given in the description block. Flag change. No flags are changed due to these instructions. Now the operation. By using this instruction, the immediate data 25h is transferred into the accumulator. See, 25h is the immediate data which is directly transferred into the accumulator. After execution of this instruction, the content of accumulator is become 25h. The more examples are move r1 comma hash 10h, move r3 comma hash 90h, move dptr comma hash 1600h. Now the next instruction is move a comma rn. See with example, move a comma r5. Here only 1 byte is required cause opcode is present but in operand no data is present. That's why this is 1 byte instruction. Addressing mode. This is the register addressing mode cause here source and destination both are registers. Next flag change. No flags are changed due to these instructions. Now the operation. By using this instruction, transfer the content of R5 to the accumulator. See, if the content of R5 is 79H, then this content will transfer into the accumulator. After execution of this instruction, the content of accumulator is become 79H. The more example for these instructions, move R1, A, move R1, R2. See the next instruction, move a address. See the example, move a 60h. Here 2 bytes are required. Addressing mode is direct addressing mode cause here address is given. Now the flags change, no flags are changed. Now the operation. By using this instruction, the transfer the contents of RAM location 60h to the accumulator. See, this is the memory location. Now microcontroller goes on the memory location 60h and find out the contents, and that contents is transferred into the accumulator. After execution of this instruction, the content of accumulator is become 10H. The more examples are move R1, 70H, move DPTR, 1670H. See the next instruction, move A, @RI. See the example, move A, @R1. This is the 1 byte instruction. Addressing mode is register indirect addressing mode. Cause here indirect sign, that is @ is present. So this is register indirect addressing mode. No flags are affected due to this instruction. Now the operation. R1 stores the 8-bit address on which the data is present and this data is transferred to the accumulator. See, if the content of R1 is 60H, then microcontroller goes on the 60H memory location and find out the contents and transfer these contents into the accumulator. After the execution of this instruction, the content of accumulator is become 10H. Now the next instruction is move X A, @DPTR. This is the 1 byte instruction. Addressing mode is register indirect addressing mode. Flags change, no flags are affected due to this instruction. Now the operation. Transfer the contents from the memory location pointed by the DPTR into the accumulator. DPTR could have a 16-bit address such as 1243H. See, if the content of DPTR is 1243H, then microcontroller goes on this memory location, that is 1243H, and find the contents and transfer these contents into the accumulator. After the execution of this instruction, the content of accumulator is become 40H. See the next instruction, move C A, @A plus DPTR. This is the 1 byte instruction. Addressing mode is, this instruction is of indexed addressing mode. No flags are affected due to these instructions. Now the operation, the addition of content of accumulator and DPTR forms an address on which contents are present and that contents transferred to the accumulator. See, if the content of accumulator is 10H and the content of DPTR is 1600H, then microcontroller will perform the addition of these two registers A plus DPTR, so 10H plus 1600H. Now the effective address is 1610H. Now microcontroller goes on this memory location, that is 1610H, and find out the contents and transfer these contents into the accumulator. See, the previous contents of accumulator is 10H, but after the execution of this instruction, the content of accumulator is become F1H. The more example for this, move A, @A plus PC. The next instructions are push and pop instruction. These instructions are used for stack memory. Stack memory is a temporary memory which is initialized in the internal RAM area. This memory works on the principle of first in last out or last in first out principle. Means what? The data which entered first is exit last. Any 8-bit data can be stored and retrieved from the stack using push and pop instruction with the help of stack pointer. See this diagram. By using push instruction, the data will be entered and it will be top. At the time of exit, it will be out at first by using pop instruction. See the push instruction. Using push operation, stack pointer increase first and then content of register or memory will store on the stack location we stored in the stack pointer. What is stack pointer? I already explained in the second video. Please go through that. Let's see push instruction with example. Push R6. Here only 1 byte is required. Addressing mode is register addressing mode. No flags are changed. Now see the operation. By using this instruction, the content of R6 is stored into the stack memory on top. See, if the content of R6 is 12H and this is the stack memory. Currently 07H is the stack top and this address is held by stack pointer. Now, during the execution of this instruction, microcontroller will increase the stack pointer by 1. So now the 08 is the stack top. and the content of R6 is transferred into this stack top. Now pop instruction. In this, retrieve the data first and then stack pointer decrease by 1. See the example pop 20h. This is 2-byte instruction. Addressing mode is direct addressing mode. No flags are changed due to these instructions. Now the operation. The content of 0 at h locations means stack top will copy into the 20h, then stack pointer decrease by 1. See how? This is the stack memory. Currently 0 at h is the stack top and stack pointer hold this address. So now the content of 0 at h location is transferred into the main memory locations 20h. See, after execution of this instruction, the content of 20h is become 12h and stack pointer will be decreased by 1. And now the stack top is 07h location. Next is exchange instruction. These instructions are used to exchange the data between two registers. See the first instruction XCH A, R1. Here 1 byte is required. Addressing mode is register addressing mode. No flags are changed. By using this instruction, the content of accumulator and register R1 are exchanged. See, if the content of accumulator is 15h and the content of R1 is 32h, then after the execution of this instruction, the content of accumulator is become 32h and the content of register R1 is 15h because the contents are exchanged. See the next instruction XCHD A, R0. Here 1 byte is required. Addressing mode is register addressing mode. No flags are changed. Now the operation. The lower nibble, that means LSB digit in accumulator and lower nibble of R0 get exchanged. See, if the content of accumulator is 15h and the content of R0 is 39h, then after the execution of this instruction, the content of accumulator is become 19h, 19h. Cause LSB digit is exchanged and the content of R0 is 35h cause LSB digit is exchanged. These all are the data transfer instructions. Next instruction set we will see in the upcoming videos in detail. If you like this video, please like it, share it and subscribe it. Thank you for watching.